Everyone, how you people are doing? I hope you people are following these video lectures as well as AES modules and must have got the concept of this number system. I'm sorry we have kept today's class a bit early, but I hope there won't be much problem for you people. In this chapter, in previous videos, we have discussed almost all the variety of problems, some more exercises also in form of worksheets were given to you. You must have practiced them also. But let us do some more problems. As you can see, that today's topic is some higher order thinking skill questions, HOTS questions, right? Such questions you may find in other reference books. In your NCERT book also, one or two such examples before each exercise are given. One more publication is there, NCERT publication, that is NCERT Exemplar. NCERT Exemplar. Right. This book is also a very good book. You can refer this book. It doesn't contain much explanation. It contains only the key points of concept as well as questions, solved examples and questions for practice. So some questions I have taken, and those questions we are going to discuss now. Let us come to the point direct. Some questions let us discuss. Suppose there is a question. Say x is 9 plus 4 root 5 and then find root x minus 1 upon root x. Right, students? One more thing I want to tell you, that these questions in beginning that we are discussing are from module 5, which is already given to you. So you can refer that module. And after that some more questions will take. Now in this kind of problem, if we start in a direct manner, that if I put the value of root x and then I do minus 1 upon root x, isn't it? And I take LCM, it may be time taking. So let us see this number x in another perspective. Can we write it as a whole square of something? If you split this term into this manner, 2 into 2 into root 5, right? And now 9, if you see, 9 can be seen as 5 plus 4, isn't it? So 9 I have written 5 plus 4, and this 4 root 5 I am going to write 2 into root 5. And now if you see, there is a connect among all these three terms. This can be written as root 5 square, 4 can be written as 2 square, right? And do you remember what is this value? A square plus b square plus twice of ab. This is nothing but a plus b whole square. So if you want to write this expression in terms of whole square, you should bring it in this form, right? There should be one a square term, one b square term, and there should be another term containing 2 into a into b. So this is happening here. So 2 into root 5 into 2. So this can be nothing. This is nothing but 2 plus root 5 or root 5 plus 2 whole square, right? Students, this is x. Now when I find root x will be nothing but simply 2 plus root 5, isn't it? Now from here, finding 1 upon root x is also essential for us. We will find, but it won't be difficult. Let us see what will be 1 upon root x. So 1 upon root x, no problem. 2 plus root 5. Let us write, right? Then when the denominator is containing irrationals, to rationalize the denominator, you know, the way is you multiply in numerator and denominator with which number? With 2 minus root 5, right? Or root 5 is bigger, so root 5 minus 2 also will work. It won't affect our answer. Let us simplify. This into 1 means 2 minus root 5 divided by a plus b into a minus b is equal to what? Is equal to a square minus b square. This will become 2 square minus root 5 whole square means minus 5. So how much it will become? It will become 2 minus root 5 whole upon 4 minus 5 means minus 5. Finally root 5 minus 2, isn't it? And now what we have to find out? We have to evaluate the number. Which number? Root x minus 1 upon root x. Let's put the value. Root x was 2 plus root 5 for us, isn't it? And minus 1 upon root x is root 5 minus 2. And if you simplify, how much it will become? 4. And that's our answer, right? So overall approach in this entire question was what? This number whose root x and whose 1 upon root x we wanted to find, that should be seen as a perfect square of some number, right? This is. Let us move on to the next problem of module 5. And the next problem is another similar kind of question, that we have to simplify. What to simplify? We have to simplify 5 plus 2 root 6 within square root sign plus 8 minus 2 root 15 within square root sign, right? This is similar work. Let us see this number as whole square of something. To do that, I'm going to write this term in a manner 2ab, isn't it? After that, I will think that okay, so 5 should be split it as the sum of 2 which numbers, right? So this I'm going to write 2ab in a manner 2ab. I have to write. So root 6. How to split? Root 2 into root 3 I can write. So I'm going to write root 6 as root 2 into root 3, isn't it? Now 5 should be written as in this manner. 2 plus 3, isn't it? 2 plus 3 is 5, right? And 2 actually was root 2 square and root 3 square was 3, right? And this will become root 2 plus root 3 whole square, isn't it? Let me write in a proper manner. Whole square root also was there, isn't it? This was only first term, and the other term is this 2 root 15. I am going to write 2 into root 5 into root 3, isn't it? Then minus sign, and 8 is 5 plus 3. So 5 plus 5 I will see as root 5 square plus 3 I will see as root 3 square, isn't it? And the whole square root symbol was also there. Some people what they do, they first simplify first term separately and second term separately. That is, I feel it is better, because writing both the terms simultaneously may be confusing. So you can simplify first term separately and second term separately, and then we can club them, right? No issue, I have written them together. Let us write this term also. This term, now here is one important point. You see, suppose you have this expression a square plus b square plus twice a, right? This is whole square of what? This is whole square of a plus b, is it? There is no doubt in that. But suppose you have this term a square plus b square minus 2ab, right? Then for this expression, what will you write? Is it the whole square of a minus b, or it is the whole square of b minus b? What? It can be the value of both. Any of this we can write. But because we have to take the square root, isn't it? So square root, if I write it as root 3 minus root 5 whole square, and then I take a square. The square root is defined only for positive numbers. It is not defined, right? So thing is, I have to write it as the bigger number first. Root 5 minus root 3 whole square. I have to write. And now when you simplify, root and square both are opposite process of each other. Both will nullify the effect, right? This will become root 2 plus root 3, and this will become root 5 minus root 3, isn't it? And what will be the answer? The answer will be root 2 plus root 5. That's it. Correct? So if you analyze the whole thing, overall what we have done in this question, right? We have done the same work as we have done in the previous question. What? That writing the number, the irrational number in a manner, as a whole square of something, right? This is. Now let us see some more questions in which some doubts, some confusions may be there. Let us see. But if you observe this point, it is interesting, right? Well, especially when we take a square root. Now, let us see one question of arrangement. In one question, there is a question to arrange 4 root 5, 5 root 3, 10, 3 root 7, and 6 root 2 in ascending order. Ascending or descending, whatever. But how to compare these ones, right? Because some numbers are here rational, some are irrational, and in irrational also root 3 and root 7. Without finding the exact value, it is by weighing only, it is difficult to tell that which one is greater, right? So if we can write all the numbers as a square root of something, then within the square roots we can compare that which number is bigger. So can we write them, all of them, as a square root of something? Let's try. See, 4 square you find and send within the square root as multiplier. So this will become 4 square is 16, right? 4 root 5 actually is root of 16 into 5, isn't it? Next, so this will become root of 16 into 5, 80. This will become root of 25 into 3, 75, right? 10. Direct you can tell that this is square root of what? Root 100. This is the value of root 100, right? 3 square, 9. Send inside the root. 9 into 7, 63, right? 6 square is 36. 36, send within square root. 36 into 2, 72. Root 70. These are the values. Now, it is not difficult to arrange them in an ascending manner. Ascending order means the smallest should be first, and this will be root 63, root 72, root 75, isn't it? Root 80, and root 100, right? So this is, so that's it. The actual ones you can write now. So simple. One more question of like this was there to arrange. Let us see here itself. Question 4 is to arrange what? Arrange root 3 cube root of 5 and 4th root of 8 in ascending order. Right. पिछले वाले क्वेश्चन में तो स्क्वायर रूट बना लिया था सबको, यहाँ पे तो स्क्वायर रूट नहीं है, कुछ और ही दुनिया चल रही है। यहाँ तो one is square root, the other one is cube root, and the other one is fourth root. Let us see all of them in the terms of their indices. This is 3 to the power half, this is 5 raised to the power 1 by 3, this is 8 raised to the power 1 by 4. Right? You can write it as 2 cube 2 raised to the power 3 by 4 in that way also. Now, suppose here all were square root. Square root means power how much? 1 by 2. Right? So in the fraction, if we write the powers, and can we make the denominators uniform? Yeah, the way is called is taking LCM. So if I take LCM of what? Of the respective indices. If I take LCM of 1 by 2, 1 by 3 and 1 by 4, right? 3 to 6 to 12. This 12 will be the LCM, isn't it? So if I take the LCM as 12, then let's write all the indices in terms of denominator 12. So 1 by 2 I'll write as 6 by 12. 1 by 3 I'll write as 4 upon 12. Isn't it? 4 3 are 12. 1 by 4 I'll write as 3 upon 12. 3 4s are 12. Right. And now these all the numbers. These all the numbers I can write in the manner 3 to the power 6 to the power 1 by 12. Right? You can say 12th root of 3 to the power 6. This can be written as 5 to the power 4 whole to the power 1 upon 12. This 8 to the power 4 whole to, 8 to the power 3 whole to the power 1 upon 12. Right? And now easily you can simplify. This is 3 3s 9, 9 9, 7 29, 1 by 12. Right? This is 5 square 25 25 6 25 to the power 1 upon 12. And 8 cube. 8 cube is 2 cube to cube. 2 to the power 9. 512. 512 whole to the power 1 upon 12. And now we can arrange them in ascending order. The smallest one is 512. Yeah. Third. Then this is third. Then this is second. And this is first. This is. So the final answer will be this, and this. This is the way how we can arrange them in ascending order. So little twist, little you think, and we'll get the correct approach at how to proceed further. Okay. Now, to evaluate, and of course you can show them on number line also, the value of root 6 or root 7 or likewise, what's the way? If you remember, when discussing the concept, we discussed two methods, right? Suppose the question is that root 6, you have to show a number line. Right? Then one way is that you can keep on drawing writing a triangle. Root 6 can be split as root of 4 plus 2, isn't it? Which is or root 3 plus root 2. So you can, by the method of spiral, right, it can be found like this is 1 1, this is root 2, right? Then further the right angles can be drawn. and in that manner you can find. So the method of spiral, there is one method. Another method is that root 6, or this method is valid and more useful even for the decimals also. That for one question we discussed on the last video, root 8.7, how to do, right? How the method is that suppose this is the origin 0, suppose root 6 only, then 6 units you see on the left side, then 1 unit from your side you take on the right, and the whole thing you take as diameter and draw one circle, right? And then here you draw perpendicular, right? And this number will be nothing but root of this quantity, right? This is another method. But these two methods we are not going to discuss now. There is one more method. There is a method of Pythagorean triplets. After discussing the Pythagoras theorem, you know Pythagoras theorem in कहेंगे क्या सर पुरानी चीजें रिवाइज कर रहे हैं, ठीक है. Pythagoras theorem says, suppose there is a right angle triangle and suppose this is hypotenuse, this is base and this is altitude, then what happens? Then the largest side in that right angle triangle, which is hypotenuse, the square of that side is equal to the sum of a square of the remaining two sides, right? Which is remaining two sides, a square plus b square. So this is the Pythagoras theorem. Now there are three numbers. You know which three numbers? Root m, m minus half, m minus 1 whole by 2, and m plus 1 whole upon 2, where m is a natural number. Which natural number? If you take 1, it will become 0, right? If you take m as 2, this will become 2 minus 1. From there onwards it will work, right? So m equal to more or equal to 2 you can take, right? So these numbers they always satisfy the Pythagoras identity, this identity, right? See, out of these, this m minus 1, m plus 1 whole by 2 will be bigger, right? You can compare. If you want to check whether these three numbers are satisfying this Pythagoras theorem or not, you simply have to take the square of these two numbers, the smaller one. So if I take the square of these two numbers, right, I should get the square of the third one. We'll get. Let us see how. Let me simplify. This will become, I'm going to expand the whole square. M square plus 1 minus twice m whole upon 2 square. You know, a upon b whole square is a square upon b square. So upon 4 will appear. And now further if I simplify it will become m plus, let me take LCM, 4m plus m square plus 1 minus twice m whole upon 4. And this will be equal to 4m minus 2m. How much? Plus 2m. So m square plus 1 plus 2m whole upon 4, and this will be nothing but m plus 1, and let me write it this way, whole upon 2 whole square, right? The square of this number. So these three numbers are what? Are Pythagorean triplets. Now what is the use here in drawing root 6? The use is that root 6 will be this term. So let m equal to 6. Okay, let m equal to 6. Then what you have to find? You have to find out m minus 1 whole by 2 and m plus 1 whole by 2. So root 6, then 6 minus 1 whole by 2 and 6 plus 1 whole by 2. Matlab root 6, 6 minus 1 how much? 5. 5 by 2, 2.5. 6 plus 1, 7 by 2, 3.5. Now simple. Now draw a right angle triangle, and this is the bigger one. This is the largest. This is going to be hypotenuse. ये आपको नहीं करना है, this will come automatically, you will measure from scale. Now draw a right angle triangle. Now the things are simple. Draw a right angle triangle in which 3.5 should be as hypotenuse. So how to draw? Let us draw a line, say AB, and this you take base 2.5. Okay. 3.5 should be a hypotenuse. Rough diagram if I see, the picture will be like this. This should be 3.5, right? And suppose this is 2.5, and then this we will measure. This will be automatically root 6. So this rough diagram first I have drawn. Now I have to draw it properly. So 2.5 as a base you draw. Then what you do? Make a right angle. Right? This will be right angle, 90 degree. Right? You know well how to draw a right angle. Right? Now root 6 we have to find. So leave it now. This R. Now what you do? Fill the 3.5 unit distance in your compass and make one arc. The arc will cut like this. I have taken 3.5. Let's say give the name some to this point. Say it is C. Then this BC distance will become automatically root 6. Now measure this in your compass and can show on number line. This will be root 6 unit. Right. So this is the way how we can find the value of this root of something by using the Pythagorean triplets formula. Right. This is before we conclude this lecture. Let us see some more questions. Maths, if we practice more and more questions, then only we understand the concept up to in the proper manner, right? Let us see some questions. One question is there that evaluate A. Evaluate A from the following expression that if what? If 6 upon 3 root 2 minus 2 root 3 is equal to 3 root 2 minus a root 3, right? We have to find out the value of a. How to find? We can compare left and right side, but the thing is that this denominator is given in irrational form. Let us rationalize the denominator. This will become, to rationalize the denominator, the way is very simple, that multiply with the conjugate of denominator, both in numerator and denominator. So I am going to multiply it with 3 root 2 plus 2 root 3 in numerator as well as in denominator. Right? This is, I have multiplied. Next what? And this as it is, let us copy. Next what? Next I am going to apply my square difference theorem. You know, a square difference theorem says that wherever a plus b, a minus b is written blindly, just blindly write a square minus b square. So the denominator, how much it will become? 3 root 2 whole square. 3 is 9 into 2, 18. Right? Minus 2 root 3 whole square, 4, 3, 12. And the numerator, I am going to multiply fully. 18 root 2 plus 12 root 3, and this will be equal to 3 root 2 minus a root 3. Right? Simplify. 8 minus 12 is 6. 6, 3, 18 plus 6 to the 12. And now easily you can compare that this number is equal to what? 3 root 2 is the same, delete. This will give you direct a equals to minus 2, right? So some questions are like this also, where some number maybe with heavy denominator given equal to some number in the right side, and you have to compare and you have to evaluate a certain value. Similar is one more question. Let us take here. Yes, here if A is 5 plus 2 root 6 and B is equal to 1 upon A, then evaluate A square plus B square, right? A square plus B square. Directly if you find A square, and then 1 upon A square, because B means 1 upon A, and then you take LCM, it may be lengthy. So first let us see that how much is B. B is 1 upon A. 1 upon A means 1 upon 5 plus 2 root 6. Simplify करने के लिए I should multiply with up and down with 5 minus 2 root 6. And if I multiply, the denominator will become 5 square means 25 minus 2 root 6 whole square. 2 root 6 whole square what means? कभी confusion है तो rough में लिख के then solve separately and then directly you can write. This will be 2 2 is 4 6 24. This is 24. And the numerator, this is 1 is 5 minus 2 root 6. This is 1 only. This is 5 minus 2 root 6. Right. So this is 5 plus 2 root 6. This is 5 minus 2 root 6, and I have to find out A square plus B square. So A square plus B square is 5 plus twice root 6 square plus 5 minus twice root 6 whole square. Right. If I simplify it, you know, A plus B whole square plus A minus B whole square, if you always, here itself we can do, but just for the sake of formula, if I simplify, this will give me A square plus B square plus twice AB, and this term will give me A square plus B square minus twice AB. This twice AB term will get cancelled, and always this will be equal to twice A square plus B square, right? So this will be nothing but twice 5 square plus 2 root 6 whole square, isn't it? 25 plus 24, right? How much? 49 into 2, 90. That's it. So this is the way that how we can find, simplify this kind of expressions, right? Now, let us see some similar kind of, some more twists, some more variety. I'm clearing it. Friends, this is a live session. I'll be happy if you send your queries, your doubts, your confusions to me. I'll surely respond to them. And doubts and queries you will get only when you work, when you solve. So solving is must, right? Maths or any other subject can't be learned by simply watching the videos or watching someone else doing the things. When you do yourself, you solve questions yourself, then you get the real joy, right? Let us see one question. One question was there in which express 0.6, 0.47 bar and Z plus, this is connected with plus 0.7 bar in the form P upon Q. हमने जो किए questions in the exercise that we have done were having only one number, right? Here three different questions are there, three different numbers are there, and their sum is to be written in the form P upon Q. No problem. Let us convert 0.7 bar separately in P upon Q form. This separately in P upon Q form, and 0.6 का क्या है? That is 6 upon 10, nothing, right? And then let's take x. Let's begin. Let x equals to 0.47 bar, which I am going to write in expanded form as 0.4777777, isn't it? Now multiply, because one digit is getting repeated, so as per the rule, let's multiply both the sides with 10. 10x equal to 4.777, right? And then subtract. 9x equals to 4.3, isn't it? Which means x equal to 43 upon 90, right? Right? Which means 0.47 bar is nothing but 43 upon 90. 1. Right. Now let another term, x equal to y equal to whatever, y equal to 0.7 bar, write in expanded manner, 777, etc. Multiply both sides with 10. Right, write again below this. Subtract 9y is equal to 7, which means, I am doing correct, y equals to 7 by 9, which means 0.7 bar is equal to 7 by 9. Now you have to write, you have to simplify. So this value will be equal to 0.6 plus 0.47 bar plus 0.7 bar will be equal to, let's write all the things, all the three terms in the form of fraction. So this is going to be 6 by 10. This number already we have found, 43 upon 90, and this value is 7 by 9. Okay. Now let's take the LCM. LCM will be no doubt 90. Right, so this I am going to write by 9 if I multiply. 54 upon 90. This will be already same, 43 by 90, and let's multiply 10 here. 70 upon 90. Let's add them together. 7. 9 plus 7 is 16. 167 upon 90. Right. We will try simplifying it by some number, common factor, if it is possible. Otherwise, leave as it is, declaring it as our answer. Thank you, students. That's all. There are further more doubts, more twists, varieties. I'll be trying leaving this some more questions for you in the form of PDF or whatever. I'll be happy to see your doubts, and I'll be even happier that if you solve complete your work properly in the proper manner. One more doubt many people ask, that what to write in the class, what to write in the notebook. Students, from the modules that have been provided to you or from video lecture, first of all write the theory part, the formula, the concept, right? For example, for explaining the things that I have written on the board in the beginning lectures, right? Those things you write. After that, compulsorily NCERT questions must be solved, right? All the exercises must be solved. Examples, as far as examples, AES worksheets. Worksheets only contain questions, so write all the questions, then solve them. From modules, need not to write all the explanation part, only the questions. If they are different from your NCERT book, that also you can solve, right? Yes, sir. 47. No, that's right. That's right. Maybe some doubt. Maybe we'll see. So this is now. So that's what I am requesting you. Apart from this, whatever the more questions, so solving NCERT questions and worksheet questions is compulsory for all. There is no doubt in that, right? The two worksheets which have been provided in this chapter to you, and NCERT questions that will be solved compulsorily. Apart from that, if at all any supplementary questions material is there, I'll send you, but you don't forget to send your doubts and confusions to me. I'll be happy. Hope this lockdown will be over and we'll be able to see each other and to meet each other. Thank you everyone for watching, and keep learning, keep enjoying. Thank you.